Welcome guys to our DSA challenge series. This is the phase 1 of our series and the questions that we are tackling in this series are based on arrays. The question that we are going to see today is maximize the topmost element after k moves. The question says you are given a zero index integer array nums representing the contents of a pile where nums at the index of 0 is the topmost element of the pile. In one move, you can perform either of the following. If the pile is not empty, remove the topmost element of the pile, or if there are one or more removed elements, add any one of them back onto the pile. This element becomes the new topmost element. When you will add the element, it will become the nums at the index of 0, that is the new topmost element. You are also given an integer k, which denotes the total number of moves that we need to make. Return the maximum value of the topmost element of the pile, possibly after exactly k moves. In case it is not possible to obtain a non-empty pile after k moves, then we will return -1. So let us understand the question with the help of an example. Here the nums is 522406. The number of moves that we can make are 4. So the very first move that we can make is only of removing the elements. Since we don't have any removed element, so we cannot add. So we have only the one option that we can remove the element. So in the first move, we are removing the element 5. Then in the second move, we are removing the element 2. Then in the third move, we are removing the element 2. Now we have made exactly 3 moves. We can make a total of 4 moves. We are at index 4. We are at index 3, the element is 4. Now we have two options. If we remove 4, then the topmost element will become 0. If we replace 4 with the maximum element, the topmost element will become 5. So what we will do, we will replace 4 with 5 and the maximum element of the pile will be 5 and we will return that 5. So let us now see the approach of the question. The very first step that we are going to do is we are going to check if it is possible to obtain a non-empty pile or not. If it is not possible, then we will directly return -1. If it is possible, then we will initialize a variable maximum with a value as 0. Now we will iterate through the entire vector till k-1 and find the maximum element. After that, we are going to check. Now in the kth move, we will have only two options. Either we can remove the element or we can replace the element. So we will check if we remove the element, then the topmost element will be element present at the next index. So we will compare that element present at the next index with the maximum element. Maximum is the elements that we have removed maximum out of. So we will compare if the element present at the next index is greater than the maximum. If it is greater, then we will remove the element and return the element present at the next index. Else we will return the maximum. So this will be our approach for this particular question. Now let us see the code. In line number 4, what we are going to check is whether it is possible to obtain a non-empty pile or not. If nums.size is double equals to 1 and k mod 2 is not equal to 0, then we will directly return -1 because in this case it is not possible to obtain a non-empty pile. We can see this with the help of example. If nums contains only one element, that is 1, and if the number of moves are odd, like 3. So what we can do, in the first move we will remove, in the second move we will add, and in the third move we will have only option of removing. And in this case we will obtain an empty pile. So we will directly return -1. Else if there is only one element and k mod 2 is double equals to 0, it means 2, 4, 6, 8. These types of moves are there. Then the maximum element will only be nums at the index of 0, since it is containing only a single element. If k double equals to 0, in line number 6, we are applying a condition if k double equals to 0. It means we cannot apply any move. So the element present at the nums at the index of 0 is only our topmost element and we will directly return it. If k double equals to 1, that means we can only do one move. And in a single move, we have only one option of removing the element. So we will directly return an element present at nums at the index of 1. So these were some of the edge cases that we are dealing with. Now let us look at the approach that we have discussed. We are initializing a variable maximum with 0. Then we are iterating through the k-1 elements of the vector. And in that k-1 elements, we are obtaining the maximum element out of them. using maximum equal to max, maximum, comma, nums at the index of I. Now we have performed k minus 1 moves. Now we are on the kth. We have only two options. Either we can remove it or we can replace it. So we will compare the element present at the index plus 1, that is nums at the index of I, is greater than maximum or not. If it is greater than maximum, then we will directly return nums at the index of I. Otherwise, we will return maximum. So this was the code. I hope the time complexity of this code is big O of n because we are iterating through the entire vector. And the space complexity is big O of 1 because we are using the constant space. I hope the question is clear to you all. If yes, share it with your friends and subscribe to our channel. Thank you.